In this animation, I want to demonstrate the intuition behind why my result of a parallel aperture and the result of a tilted aperture in your reference work behave so similarly, at least for small angles. As we discussed, the formulas seemed the same, at least up to the second order of the angles. So what I've drawn here is the schematic of this. So we have a pixel here where the thin film is located, and then we have this plane here where the aperture, at least the parallel aperture, will be located. And in blue I have drawn a tilted aperture, and in red I have drawn an equivalent parallel aperture. And this equivalent parallel aperture is obtained by projecting the blue tilted aperture onto the aperture plane along the rays of incident light, so not with collimated light. And so the key property here to make this comparison possible is that both apertures, the blue one and the red one, they have the exact same distribution of incident angles, which are incident on the pixel. So then we can compare them. And so that means that a tilted aperture can be interpreted as an equivalent parallel aperture. And then we see how different they are. What follows from this drawing, at least qualitatively, is that for small tilt angles, that the chief ray angle, which is defined by this red line here, is almost the same as the tilt angle of the blue one. And when I enlarge it a bit, you can see it better. The chief ray angle here is almost identical to the tilt angle defined by the blue line here. And this explains, at least qualitatively, why the results can be interpreted as the same thing. Because if you just interpret chief ray angle as a tilt angle and then use the formula from your book, this drawing explains why you would get approximately the same result.